All right, you guys, welcome to the second review preview session for ENGI at 1331. Part of our review session is going to be arrays. So we're going to be talking about the differences between row vectors, column vectors, and matrices. We're going to be talking about indexing them and concatenating them. Next, we're going to go over the menu function and then the plot function. Our preview section is going to talk about user-defined functions, which is something you guys are going to go over next week coming up. So arrays. So last time when I talked about arrays, I basically just said that they were sets of data, right? So it wasn't a variable holding one value, but it was a variable holding multiple values, right? If we run this, R becomes a row vector, right? Because it's got one row, any number of columns. C becomes a column vector because it's one column, any number of rows. And M would be a matrix. So notice how I separated the elements in R with a comma and the elements in C with the colon, right? So whenever the colon was used, we jumped to a new row basically. And whenever the comma was used, we jumped to a new column, right? So we're going to use that in the creation of our matrix. We're going to use both. But you'll see that M is a 2 by 2 now, right? Because the comma corresponded to putting it on a new column, same row, and the semicolon corresponded to a new row, right? And we separated 30 and 40 with a comma. With vectors, you can also create them with an increment. So if we do this again, but instead we say 1:5, what we'll get is a row vector with the values of 1 through 5 in it. So we can also use an increment here. So we can say start at 2, jump 2, stop at 10. So here we started at 2, jumped 2 every time, and stopped at 10. And so the way to make this a column vector is what we're going to use is the transpose. So that's basically just an apostrophe at the end of the creation. And what it does, it basically takes all the numbers that were here and swings them down over here. Just kind of reorients it. We can also index these arrays. And so by indexing, I mean we can go into these sets and get out specific values. We run this. X will store 20. And 20 is located at row 1, column 2 of M. Row 1, column 2, right? So the first index corresponds to the row. The second index corresponds to the column. We can also change the values in a matrix. So if we say 1, 2, becomes, we can put any value here, so 7. And M at row 1, column 2 became 7. So we can also pull out entire vectors, so like sections of M. So we can say M at, say we wanted the whole row, the whole first row of M. We could say row 1, right? We want all the columns of that row. So the colon in the spot of an index signifies all of that dimension. Right, so we went into M, took the first row off. And so with vectors, it's a little, indexing is also a little different. It's a little easier. MATLAB can recognize if you are indexing inside of a row vector or a column vector. We run this. Let's see. So R at 3, column 3, since it's the only changing dimension, F is 30. R at column 3 is 30. And C at row 3, since it's the only changing dimension, is 70. And G holds 70. So MATLAB kind of recognizes which dimension is changing and indexes off that. So like I said, we can change the value in M. So if we were to say all rows second column, meaning we want to take this off of M, and we run it, that's okay. And M just becomes, it loses this column because we said second column. These matrices and vectors can also be concatenated. And by that, we mean you can stick them together. If I were to say M becomes R, comma C. So basically what I'm saying is I want to put the vector R first and then C next to it in the same row, right? Because we're using a comma. So if I run this, I get an error. Dimensions of arrays are being concatenated are not consistent. And so the reason for that is because we tried to take R and put C, which is a column vector, next to it, right? Because we used a comma, so it had to go next to it. And MATLAB doesn't like this empty space right here. So maybe if I were to say R1 becomes could put R1 next to M and nothing would happen. Or next to R and nothing would happen, right? Because we took R, 10 through 40, put it here, and then put R1 next to it. And so as you can see, the rule here is that if you're trying to put two things on the same row, meaning you're separating them using a comma during the creation of them, both must have the same number of rows. So this is R. If R was 2 rows and R1 was 1 row, we'd have this blank space right here because we want a full rectangle. If we're trying to put two things on the same column, they have to have the same number of columns, okay? So if we were to trying to put, let's say R1 was 1, 2, 3, okay? So R1 is now a 1 by 3, R is now 1 by 4. If we tried to put them on the same column, so we say R, R1, we get an error. The reason why that happens is because we tried to put R here and R1 on the next row because we use a semicolon. That doesn't work because, again, we have white space here. So next we're going to talk about menu. So menu basically just allows for more user input, except this time the user has a definite set of choices they get to pick from. So they can't say whatever they want. Let's say choice becomes input. What's your and we want a string, right? Run this. We could put anything we want here, right? I could put pizza and it would accept it. But if we want to give the user, so right here, when we open the parentheses, we'll see we'll need a message, opt1, opt2, all the way through opt-n. And so our message is going to be the prompt we want to ask the user. So again, what's your favorite color? So let's say red, green, blue. So these are 3 options the user is going to be able to pick from. And notice how I use apostrophes, just like an input to define all these things. So if I run this, you'll get a pop-up menu. What's your favorite color is your prompt, and your options are right here. So if I click red, notice that choice doesn't store red. It stores a value of 1. And the reason it stores a value of 1 is because red was the first option listed inside of my menu. So it was the first option listed here, and it was also the first option that popped up. If you wanted to say, we wanted to tell them what their favorite color is, we don't have a variable to put here. If we say choice, choice only holds a value of 1. We don't know the actual string that tells them what their favorite color is. And so the way to accomplish this is to put your options in a string array. So we can do this by saying options, but instead of single quotes, simplifying a char array, we'll just use a string array. And then options can be our options. And instead of using choice to print to the window, we'll index options at choice. So since options is listed red, green, blue, it also appears in our menu in that order. So when we click on a color, it corresponds to that color's index in options and then prints that out. With numerical arrays, it's a little different. So if we were to use 10, 20, 30, 40 as options, run it, we wouldn't get all the options. To get around this, use the function num2cell to convert a number array to a cell array. And use option C as our choices, and then index options at choice. And then if I want to put %0.0f here, it would have worked. Another thing y'all have been working with is plot. We call the plot function. We open up these parentheses. We see it calls for x, y, line spec x1, y1, all the way to xn, yn. So if we use x here and y here, these two variables I put in here also don't have to correspond to that it's calling for x and y. So like if I were to name these something else, like let's say a b, I don't have to use xy here. I can still use ab, right? It's just calling for the variable that's going to be giving us our x values and the variable that's going to be giving us our y values. And so line spec has to deal with the formatting that we want on our graph. So if I go up here, I look up plot, and I scroll all the way down. You got to scroll down for a while. You'll see this table right here. And so basically what line spec does is it tells us what kind of line, what kind of marker, or what kind of color we want on our graph for this data right here. So if I put an O, marker O gives me a circle. And I close everything off. We have blue circles. And so that x1, y1, xn, yn thing, you can also do this for multiple sets of data. So if I had another x and another y, I can also put these in here. So if I said a1 and b1 and I had defined them, I could put their formatting after that and then close it off. Let's say we want these to be red circles. We want these to be blue circles. We give it, right, so we have our different values plotted with different formatting. This table, along with some other stuff you're going to learn later in the course, is going to be included when you guys take exams. So we're going to give you a sheet with all this information on it. So in this next section, I want to talk about user-defined functions. So in the last video, I told you guys to never think of functions as just keywords that magically do things for us. And I showed you guys that functions are actually just blocks of code themselves. So last time I showed you guys, this is a function that I wrote that takes a vector and sorts it from lowest to highest. So if you go up in the top left corner right here, click on this down arrow under new and click on function, it opens up a new function script for us. And so basically this is like the shell of a function. Every function is going to have, it's going to start with the function keyword, its output arguments in brackets, an equal sign, and then its title. And then its input arguments inside of parentheses. This stuff right here is just some extra stuff that MATLAB includes. And every function will be terminated with an end statement. There are a couple of points I'd like to make about functions before we write one. So let's go ahead and name this, since I already know what we're going to do with it. I'm going to name it magnitude. Click this down arrow, save as. And so we want to make sure that this name right here matches what we save it under. So it'll be magnitude.m because its name is magnitude. We also want to make sure it's in the same folder as the script that we're going to be calling it from. So session2.m has to be in the same folder as magnitude.m. Our function will only know what we input to it and what we write inside of it. So if we define a variable here, say x equals 2, and we called our function, so we said v, or let's say m becomes mag of v, and we had a vector v. Magnitude, if we only had the input as v, and say our output was m, and we tried to say fprintf we try to put x here, the function will not recognize it as a valid variable because we didn't import it. The same thing goes for our outputs. So if we were to define a variable x in here and not here, and we should try to print out f in this script will not know what it is because it was not outputted from the function. It only outputted m. So let's write a function that calculates the magnitude of vector in 3 space. So if we define a vector v here, and we want to use the magnitude function to calculate the magnitude of it. V is our input. V becomes v. And to calculate the magnitude, we say, so we save this. M becomes 9.8995, which is the magnitude of our vector. So say if you had 10 magnitudes you needed to calculate, you don't want to type out v at 1 squared, v at 2 squared, v at 3 squared, square root of that every time, right? You just want to call this magnitude function and have it do it for you.